All right, and welcome back for part two of the video. Uh, Unfortunately, like I said, I kind of had to go there earlier, stop filming. So here we go for the last couple examples. Now, there are a couple things that I want to point out. So you've been following along, hopefully. I am going to just pause and go back for a moment to example number one. Okay, where I solved for these two solutions here. Okay. Um, the idea here, okay, where I solve for my, let's see here. This is four. Okay, let's take a look here. So I just want to take a look here at tan of x equal to 0 and tan of x equal to 4. Okay? Because I kind of talked about adding the period there. And I know that maybe that solution, so that's something that I may have touched on briefly, but I'm just going to, earlier or last unit, but I'm just going to go over another way that you could solve that. Because after thinking about it, I was like, well, maybe that might not have made sense to everyone. So I'm just going to go over that example again. So what I'm going to focus on here, as I said, is I'm going to focus on these two here, tan of x equal to 0 and tan of x equal to 4. Okay, and I'm just going to zoom out and bring that kind of right to here. Okay, so tan x equal to 0. Okay, so if I want to solve that, I mean, typically what I'm going to do with this is I'm going to bring my tan over, and I'm going to get that x equals the tan inverse of 0. And if I put that into my calculator, right, second tan of 0 equals, and I get 0. Okay, so I get x equal to 0. So that's a solution. Now, again, with these ones, when you have tan or sine or cos equal to 0 or 1 or negative 1, those are kind of examples that you can solve with the graph, okay? By looking at the graph and just investigating or inspecting the graph. So I know that the tan graph looks something like this, okay? Let me extend that a little bit. Right? So knowing these graphs is going to make doing these questions a lot easier for you. Okay. Now, I'm not telling you that you need to memorize this stuff, but memorizing it may help. Okay. It's certainly, I've done this for a while. Knowing these graphs and what these graphs look like makes solving these questions a whole lot easier for me. Okay. I don't necessarily need to even use my calculator for questions like this if I just think of what the graph looks like. So I know that the period of the tan function is pi. Okay. So I know that it repeats itself after pi. And I know that this is roughly what the graph of tan looks like over the course of 2 pi. So if I'm looking for when tan is 0, I can see pretty clearly from the graph that tan is 0 right here, and right here. So I know those solutions based on that are 0, pi, and 2 pi. Okay. Now, again, like I said, knowing the graph allows me to come up with those solutions. Okay. So those are my first ones there 0, pi, and 2 pi. Okay. You can also think of that. Excuse me. You can also think of that as tan, right? We know that tan theta is equal to y over x. Okay, well, if you think of that on a Cartesian, what makes y over x 0? Well, if y is 0, okay, if y is 0, 0 divided by whatever x is going to be 0. So where on our unit circle, so if we think of this as kind of our unit circle, where are our y values 0? Well, our y values are 0 right here at pi, and our y values are 0 right here. And we know that this is 0 and 2 pi. So that's another way to kind of find your solutions. Okay? Now, the other one that I did want to look at was I wanted to look at, okay, what about when the tan of x is equal to 4? Okay. Well, in order to do this one, I'm going to do the same thing. I'm going to bring tan over. And what I get when I do that is I get x equal to tan negative 1 of 4. Okay. We're going to use our calculator for that. Okay. Second tan of 4 equals 1.32. So we get x equal to 1.32. Now, what is that exactly? Remember, when we're solving here, we're solving for angles. So where is 1.32? Or you can think of it this way. Where is the tan of x or theta a positive value? Well, we think of C, A, S, T, cast, cast, cast. Tan is positive here and here. So that 1.32 is this angle right here. And then the other angle I need to find, the other solution, is this solution right here. And that solution is pi plus 1.32. Okay? And this here is how I got that value for, I think it was what? It was 4.3, so that's 4, 6 or 7, 4.46 or 47, right? If I go back to my question, here's my question. Those are the solutions I got. So I got 4.46, 2 pi, 1.32, and 0. Okay? So again, just another way to kind of find those solutions there. Okay, back to it. Let's get to these last two examples. And just again, very important, I just want to stress here the importance of being able to solve these questions. You really need to be confident, and practice is what's gonna help this. You really need to be confident in solving these things. Cos x equal to a half, or where's the other word? Cos x equal to -1, or wow, sorry about that. Or like I said, tan x equal to 0, or tan x equal to 4, or right, these values, these kind of linear, we'll call them, you need to be confident in solving, because that's how you find and finish off these types of questions. Okay, so let's do this next one. Okay, and I'm just going to write a little note for this one. For questions like this, we want to express these equations using only one trig ratio. Okay, so specifically, we want them to be written all in terms of sine, or we want them to be written all in terms of cos, or we want them to be written all in terms of tan. Okay, so that's how we solve these. So noticing then that this one here, sine x equals cos 2x, has sine and cos in it. So my first step here is to make this all either sine or cos. Now, again, this is where it comes in handy to kind of not only, right, you're going to get your formula sheet on this test, but it's not, it's important that it's obviously important that you have the formula sheet, but it's more important that you understand the formula sheet and you know what's on the formula sheet. Because right away, I look at this and I see cos 2x. And I know that cos 2x is equal to, and if I just pull up my formula sheet here, if I think I can do it, nope. Let me just pause this for a second. I'm just going to make sure I have my formula sheet up. Okay, looking at my formula sheet here, I know that, where is it? There it is. Cos 2 theta has these three options. Now remember, I said I want to write this all in terms of either sine or cos or tan. So if that's the case, then I'm going to specifically use this one here, because notice that this one is just sine, okay? And we obviously that it's a sine squared, which means we're going to have a quadratic. So I'm going to write this in terms of, what was it again? It was 1 minus 2 sine theta. So I'm going to say, okay, sine x equals 1 minus 2 sine squared x. Okay. Now your variables are interchangeable. Obviously, we have thetas here. Theta can be written as x. These are just variables. They're just placeholders. Okay. I'm going to bring everything over to my left side. So I'm going to grab this, bring it over, and the 1, and bring it over. That becomes 2 sine square x plus sine x minus 1 equals 0. Okay, I'm going to say here, let sine x equal x. So I'm going to write this as 2x squared plus x minus 1 equals 0. I think this is going to factor just the same as we had earlier. Yes, it is. So I'm not going to give you, so one thing to kind of note here, I'm not going to give you anything that's, let me just zoom out, anything that's too crazy factoring, okay? Because we've been factoring a lot, but you're still going to need to know how to factor, okay? A complex trinomial or a simple trinomial, okay? Now notice, just for the sake of this lesson, I've used the same one a few times here, okay? So then this means that my solutions are x equal to 1 over 2 or x equal to negative 1, okay? Now I'm going to take this, I'm going to sub sine back in, so I have sine x equal to 1 over 2. I'll zoom in just a moment. And for this one, I have sine x equal to negative 1. Okay? So continuing along here, when is sine x a half? Well, I can bring this over. I can take the sine inverse, so I get x equals the sine inverse of 1 over 2. Okay, actually, I'm going to solve this one. You know what? I'm going to pause for a second. I'm going to solve this one without a calculator, because I know that some of us don't have the calculator, that gives us exact values. So we know that sine is y over r. Okay, so this is without a calculator. Sine is positive in this quadrant and this quadrant. So that tells me that this is my y, 2. And then knowing my special triangles, this is root 3. So filling in my special triangles, that's pi over 6. This is pi over 6. So that means that this angle here is the other one that I need to know, and that's going to be 5 pi over 6. So my solutions here are x equal pi over 6 and 5 pi over 6. Okay? Again, continuing without a calculator here, if I think of this one in terms of the sine graph, okay, I always like to do it this way. My sine graph looks like this. Actually, let's do purple. My sine graph looks like this. Where is sine negative 1? Well, that's right here. And what is that value? Well, we can count here. This is 2 pi. This is pi. This is pi over 2. And hopefully we have this memorized. But if you're not sure, this is 1 pi over 2. 2 pi over 2. Actually, let's try a different color. 1 pi over 2. 2 pi over 2. 3 pi over 2. Okay? So my solution here is x equals 3 pi over 2. Okay, and there you have your 3 solutions. Okay, now, once we have our solutions, okay, we have our solutions. Generally, our solutions, the question asks for your solutions between 0 and 2 pi, okay, because that's one period. Now, I always want to refer back to my question and make sure, is that the interval? Is this the interval they're looking between? Well, let's zoom out a little bit. And I see that the interval is asking between 0 and pi. So are any of these solutions bigger than pi? Yes, this one is, right here. 3 pi over 2 is bigger than pi, so that is actually not a solution. So my final solutions are these ones. Okay? Making sure that you get all of the solutions in the interval that are required for full marks. Okay? Now my last example here. All right, let's see if I can pull this one up here. Um, okay, so with this one here, okay, let's try this one here. So with this one here, solve this one. All right, solve this one. So let's do this one here. Let's start with this one here. So I'm gonna write it out first. Okay, so I'm gonna write cotan x cosecant squared x equals 2 cotangent x. Excuse me. Now, the issue with these questions, and this goes back to what I talked about yesterday, is that there is not always, and you've kind of seen me be doing these questions step by step. Okay? I appear to be doing a similar process each time. That process does not work for every single question. Okay, and it's important to understand that. Sometimes there you have to try different things. Okay, the step-by-step procedure that we do for most questions is not always going to work effectively. Okay, so right off the bat here, okay, and this is an example where that process might not work. Okay. And the reason I say that here is because we don't really here have anything that's cotangent is, so let's see here. I'm going to write this out like this. So cotangent of x is equal to 1 over tan of x, which is equal to cosine x over sine of x. Okay. Cosecant x is equal to 1 over sine of x. Okay? So looking at these two things, I'm not gonna be able to cancel things out. Just kind of looking at the way these fractions are working here, I'm not gonna be able to end up getting any cancellation. So I'm not gonna change anything right off the bat. Okay? And what I'm gonna recognize here is that I have kind of the cotangent here, and I have the cotangent here. Okay. Now, because this is a quadratic, we solve all quadratics the same way. We always start by bringing everything and setting the quadratic equal to 0. So that's what I'm going to start with doing. I'm going to bring this over. And I'm going to write, okay, cotangent x cosecant squared x equals, minus 2 cotangent x equals 0. Now, think back to the very first day you learned about factoring, the very first type of factoring you learned about, and also the first type of factoring we always look for in any type of question. The first type of factoring that we always look for in any type of factoring question is always common factoring. And what do these two things have in common? They both have a cotangent x. So I'm going to factor out here cotangent x. And I'm left with cosecant squared x minus 2. Okay? All right. Let's keep going. So next, what I'm going to do here is I am going to say, oh, sorry, and this is equal to 0. Well, now what I'm going to do here is I'm going to look at my brackets. Okay, and I'm going to say, well, this here is, let's focus, actually, you know what? Let's take this one step further. Okay, let's take this one step further. Because when I have two terms in a bracket, like this bracket here, how can I factor those two terms? Well, I can take the difference of squares. Okay, I'm two terms and I'm subtracting. I can do factor by difference of squares. So I'm going to do that. We will cotangent of x cosecant x minus root 2 and cosecant x, well, x plus root 2. And this is equal to 0. So now I have three factors. So I'm going to have three solutions. And my three solutions are going to be cotangent x equals 0. That's going to be 1. I'm just going to put a little 1 above it. My second one is going to be the cosecant of x equals positive 2. And the third one is going to be cosecant, cosecant of x equals negative root 2. Okay, and I'm going to try to solve each of these. All right, so to begin with, cotangent is equal to, I'm going to just swap this around. I'm just going to make this something a little different here. Cotangent of x is equal to this right here, right? We wrote that down. Cos x over sine x. So that's equal to cos x over sine x equals 0. Now I'm going to cross multiply this sine x. So I get when is cos x equal to 0? Well, we know that, right? We can think about our graph for that. I'm just going to show you our graph here. We can think about our graph for that one. And that's at, so here's this 2 pi. This is pi. This is pi over 2. And this is 3 pi over 2. So my solutions here are x equals pi over 2 and 3 pi over 2. Okay, that's my first one. So that's my first set of solutions. My second set of solutions, cosecant x equals root 2. Okay. Well, what I'm going to do here, because I actually kind of have two of these. So what I'm going to do is I'm going to look here. Cosecant, there's a couple ways to do this. Let's do it this way. Let's go like this. Cosecant is, and this will be on your formula sheets, is r over y. Okay. And cosecant, just so we remember, is the opposite of sine, right? It's the reciprocal of sine. So let's draw out my grid. So when I say cosecant is the reciprocal of sine, all it means is that cosecant is going to be positive in the same quadrants that sine would be positive. So here and here. Okay. Now if I think of my graph, right, like triangle, it's r over y. So r, that's like 2 over 1. So this is root 2. This is root 2. Y is 1. 1. This is also 1. This is negative 1. Okay, so I've filled in my special triangles. So what are these angles? Well, this angle is pi over 4. And what is this angle? Oh, did we freeze? Nope. What is that angle there? Well, that's going to be 3 pi over 4. Okay, or I'll just show you here. It's going to be, just kind of put an arrow here. It's going to be pi minus pi over 4, which is equal to 3 pi over 4. So my two solutions here are my two solutions here are x equals pi over 4 and 3 pi over 4. Okay, those are my next two solutions. Now my last one is cosecant is negative. Well, that's just going to be the opposite quadrants as our previous one. So that's going to be here and here. And this time, this is over 1. So that's equal to, again, r over y. This is negative 1. This is 1, 1, negative 1, root 2, root 2. So this is pi over 4, pi over 4. So how do I figure out these angles? My first one, and I'll do this one in blue. Actually, let's bring this one a little tighter. This angle here is going to be pi plus pi over 4. Just zoom in a little bit. And then my other angle here, which is going to be this one, is going to be 2 pi minus pi over 4. And the answers to these, well, this one is 7 pi over 4. Okay, if you're subtracting that, just get a common denominator. And this one's going to be 5 pi over 4. So those are my last two solutions. So my last two solutions are 5 pi over 4 and 7 pi over 4. And so in this question, I end up with 6 solutions. Okay. Again, I can't stress solving those linear are going to be really important. Okay. So what I'm going to do now, you can try out those questions. I am going to write up right now a test breakdown for you on a, and I'll do that right now. I'll show you here. Test breakdown. Okay, I'm going to write that up right now for you, and I'll give you some example questions or two questions to work on for each question that's going to be on your test. So I'm going to break that down off the video. You can find it on OneNote or on D2L. All right, have a good rest of your day, and we will see you all tomorrow. Please let me know if you have any questions, and tomorrow is a review period, so we will go over any questions that you have. All right, we'll talk to you tomorrow.